let me invite the technical paper number 4, Refurbishment and Modernization of Plant and Machinery for Enhancement of Business Sustainability by Tata Power Trombay. Yeah, please.
So good afternoon to all. Myself Sachin Akhade and my colleague Vivek Belkhade. So we both will be presenting our paper, that is Refurbishment and Modernization for Plant and Machinery for Enhancement of the Business Sustainability. We both are from the Coal Logistics and Plant. So these are the contents of our presentation. So starting with the introduction. So first of all, I like to introduce my organization, that is the Tata Power. So it is the India's largest integrated power company, having a diversified portfolio in the generation, transmission, distribution, serving around 12 million customers, and having also renewable portfolio around 35%, and generating capacity more than 13 gigawatt. Then coming to our Trombay thermal power station. So we had around 930 megawatt capacity. So our first 500 megawatt unit, because we had a senior person over here who were the part of our first 500 megawatt, which was commissioned in 1984, and still it is running after 40 years of this thing. And the second unit was unit 7, that is 180 megawatt, which is a combined cycle power plant commissioned in 1994. And unit 8, that is 250 megawatt, which was commissioned in 2009. So you can see that unit 5 and unit 8, these are the coal fired plant, and consuming around 9,000 tons of coal per day. So this is the bird eye view of the Trombay thermal power station. So you can see here the captive dedicated jetty where we receive the coal from the sea route, and the stockpile 1 and 2 where the storage of the coal takes place, and the unit 5, unit 8 locations, and the conveyor. So this is the schematic of our coal handling plant, where you can see the unloading jetty over here. So we had some of the sophisticated equipment for this screw unloader. Then this is the unit 8, 250 megawatt. This is unit 5, 500 megawatt, and these are our storage yards. So this is our team, our mentor Mr. Sachin Sadhu, and myself Sachin Akhade, Vivek Belkhade, and Yogesh Lokre. Now coming to the objective of our today's session, that is refurbishment and the modernization. Then why refurbishment and modernization? As we know that our generating station is in the heart of Mumbai city, and with this we are also governed by the stringent environmental norm. So you can see in the right hand side that SO2 emission and the ash generation, they are limited to 24 metric ton and 766 metric ton per day. That is the restriction which has been governed by the for this stringent environmental norm. Now because of this stringent environmental norm, we have to go for the imported coal firing. Imported coal firing with low ash and low sulfur content, and that's what we have to have a sophisticated CHP equipment which has to be maintained to unload this type of coal. Now with this imported coal firing, we invite that the landing cost of the coal is on the higher side, and it directly has an impact on our cost of generation. Now high cost of generation. Now the high cost of generation keeps us in the MOD ranking. We comes in the last page. Positioning is in the last page. Now to take care of the high cost of generation, we have to focus upon the landed cost of the coal and the O&M expenses. So So these are contributing to my variable cost. So landed cost of coal, it is beyond our purview because it is taken care by our logistics team. So where we can do something for refurbishment and modernization, that is the O&M expenses. How we can optimize our O&M expenses. So these are the different avenues where we, under the value initiatives, where we have thought how we can reduce the O&M expenses. So optimization of inventory, then optimization of AMC cost, then the spare substitution dependency from the OEM vendors, then saving through the repair and maintenance, then cost optimization in the outages, and the last is the process automation, digitalization. So these are the four areas where we thought that how we can bring down the O&M expenditure so that we can sustain in our business. Now then, coming to the life cycle mechanical component critical equipments. So refurbishment and modernization for business sustainability. So for any business, basically for Trombay, now it has become very challengeable. So for business sustenance, what are the criteria? So first is we have to be competitive in the market so that our MOD ranking can be increased, and that is only possible when we bring down our cost of generation. Now if I want to bring my cost of generation down, then I should go for the coal which is having the low cost. So my landed cost will be come down, and then only it is possible. So by default I have to fire the coal which is off spec from the which is having the specification from normal to the off spec. So but now if I want if I am going for the off spec coal firing, then it has to meet this stringent environmental norms, that is the low sulfur and the low ash. And also the another aspect is the I have to also sustain my O&M expenditure. So taking care of environment, then my this thing profit, and also the society. So to study the life cycle cost, life cycle deterioration of the critical component. So we thought why it is happening. So when we are firing this off-spec coal, so this invites the rapid wear and tear of the critical component, early wear and tear of the critical component. Because when we are handling this such type of coal, then this coal has the impurities in the form of an foreign material such as the stone, boulders, which deteriorate my service life of the component, and that increases my spare inventory. And this also increase my downtime where the low MTPF comes into picture, and has adverse impact on my critical spare availability, which are high value and the high lead time. Now in CHP there are some of the critical equipments which are located in our Trombay plant. So you can see a screw unloader, stacker reclaimer, and the pipe conveyor. This screw unloader and pipe conveyor, because of the stringent environmental law, we have to go for such sophisticated equipment, the pipe conveyor and the stacker reclaimer. Screw unloader. It is one of the first installation in our Trombay thermal power station for unloading of the coal from the barges. So because of this sophisticated equipment, the spares which has to be required for the maintenance of this particular equipment, these are high value spares which are having the high lead time, and also because of the proprietary policy, some of the OEM they are not sharing the technical specification, so we have to depend upon the OEM. So these are the some of the major components over here: the pipe conveyor belt, screw for the unloader, idler, pulleys, and the gearboxes, which are the major components which goes in the CHP equipments. So how this is impacting my this thing inventory? So you can see from this pie chart that my 48% of my inventory cost is going in the screw purchase. So and around 28% goes in my belt. Now coming to the analysis part, so we first of all taken these two major pairs, that is the belt and the screw, and we try to analyze the wear pattern of those both of the this component, because if you see this belt and the screw, they are subjected to the wear and tear as we are handling the coal. So because of the coal erosion, these two components, they are subjected to wear and tear. So using this RCM philosophy, we try to analyze this wear pattern. So we started collecting the data for both of these components, and we plotted. We have also identified some of the failure modes for both screw and the pipe conveyor. Then using this reliability distribution GAPM tool, we try to understand which type of failure pattern it is. So which is already written over here, that is the wear out pattern. Now this wear out pattern is the only area where we can do the refurbishment of any component. So to increase the lifespan of the component, especially in the wear type failure pattern, there is a scope for refurbishment over replacement. So and it has also a high impact on O&M expenditure and improve the equipment reliability. Because if you go for the refurbishment, then definitely it will give lot of savings. Now, envisaging this life cycle of the component, so we came to know that there is a sustainable extent of the life of the component. So we thought of this thing, how we can increase the service life of the component. So here we have taken the target of increasing the service life of component by 50%. So this is how we have come to our this thing refurbishment project. And now I will request my colleague Vivek to take forward this presentation.
Good afternoon everyone. I am Vivek Belkhade. I am also working with sir since 7-8 years. So I will go to the presentation first. So we will come to the refurbishment and modernization of pipe conveyor first. So this pipe conveyor belt, this was installed in 2009 in Trombay due to the norms, stringent norms, and actually this is the imported pipe conveyor, and in India you will find hardly 2 or 3 manufacturers who are developing this pipe conveyor belt. So we used to import this conveyor belt from South Korea. So and it is also having the 15 to 20% of the inventory it is costing, and almost 12 crores of rupees we require for each replacement. So we thought of going for the refurbishment, and we found out that there are no manufacturer are ready to extend the service for belt refurbishment to us. And we contacted small vendors also who do belt repairing services, but either we found they are not competent enough in refurbishing the pipe conveyor belt, or they don't have that much of facility. So the idea was to just think for the in-house refurbishment, which is a low cost and as well as having the low lead time. So we did the refurbishment step by step, just like fabrication of the bed, modification of vulcanizing machine with the in-house manpower, which is outsourced manpower. We have done the session. We have done the testing of belt sample also, because we have to find out what is the residual life in belt before doing the any kind of repairing. And then we have done the procurement of vulcanizing compound, and we have done the repairing of exposed bottom conveyor for the entire length of 55 meter belt. Then again we have tested it in the lab, and once we found it is within limit, we have installed it and we have took the trial of the belt. And these are some of the deliverables, like the reduction in OEM dependency, foreign vendors, readiness for refurbishment in case of pandemic, when you can't import any spares due to restriction, competency development, then confidence to develop the belt indigenously. So what happened is, once we have developed this belt, refurbished the belt, then we invited one of our vendor, and he visited and he witnessed our refurbishment belt, and then they invited us to develop the belt on trial basis. So with the help of this, we again developed the belt indigenously for 100 meter of the small quantity. And here you can see the difference between OEM provided refurbished and indigenization developed belt. So which is having the cost saving of almost 30% in case of refurbishment, and indigenization on 30%, 35%. So these are some of the modernization techniques for life extension and reliability improvement, such as the usage of special test in case of pipe conveyor, 6-point bend test, which is not in case of any conveyors, normal conveyors, which we have started using. And this usage of Power BI is a sort of software which is freely available, through which we can real-time monitor the pipe belt joint health condition, and also that in any case of defects we can take action well before the equipment fails. Again, we have done this repairing through the rubber gun compound, and we have done the hardness checking, conveyor belt mapping, and etc. That the best practices which we are following to improve the life. Then the idler is also, this is the pipe conveyor, it's having number of idlers, like you can say only 2 conveyors having 14,000 numbers of idlers. So again, the monitoring of same is difficult, and most of the places it is manually doing. So we have started capturing it in a digital way also, to find out where the more life is, we are getting more life or less life. Then we have optimizing idler running hours also. Idle means empty running of belt. So whenever we are capturing this, we will have running belt, not idly. So these are some of the improvements which we have done. Now coming to the refurbishment modernization of ship unloader screw. So this is a screw unloader, and this is any kind of So this is also the first installation in India for any coal application, and it is also consuming the 5 to 6 crores of spares for one-time replacement. So this, you can watch the video of a screw unloader. It is having the screws which sucks up the coal, and it is pollution. It is zero. You can say the dust emission. It is not having dust emission and pollution. That's why it was installed in the our port. So this is the wear pattern of the screw. So what we found out is there are different type of wears, like in vertical section flights, wear in flights are more, and in horizontal shafts wear in more. So a serviceable portion, either shaft or flight, can be used for refurbishment. So due to low profit margin, the vendors who are there, they are not interested. So again, we have taken up the in-house refurbishment from the salvage screw. So this was giving us the life of 5 to 40 hours earlier. Then we developed the screw with the help of our in-house team, and we have done the in-house refurbishment of the screws by using the salvage screw. Then we have done the balancing runout check. Refurbished screw was installed successfully, and it is running and giving us the 7,000 plus running hours. Yeah. So this is some of the practices which we are using. Like in design, the RTD was not there, so we have installed the RTD to prevent the early failures, because screws, there is a minimum gap, and we cannot predict any, we cannot restrict any stone or foreign material over there. It's in the logistics scope. So we have to install some machines, And we are mapping the thickness also for screws so that we can provide some wear resistant coating or something to increase the life of the screws as well. So this is our reliability improvement tracking. Like we are using Pi dashboards which are available in system, and we can access it in desktop as well as in mobile. Then usage of GAPM for real-time monitoring of our KPIs and maintenance parameter. As well as we are tracking our plant inventory in monthly SDM meeting. So these are the benefits of our and sustainability, like the service life of belt and screws were increased. Again, you can say the spare inventory trend which was reduced for Trombay as well as for CHP from 9.63 crores to 7.12 crores. So major contribution was from this screw and belt, because which we are importing from the Korea as well as from Sweden. So this was our mainly achievement. So the knowledge sharing that this we have discussed with the other divisions also in the platform COI called Community of Interest. And again this was presented in the Power Innovista, and the refurbishment of belt was selected in Tata Group level Innothon platform as well. Thank you.
Well in time. Question? Question, please. No question? So no question. Thank you very much.
Yeah, just one question.
Yeah, please.
Screw element. How you made it actually? Any welding process? How the wear area has been redeveloped?
No, what I have shown, like some of the screws which are in vertical direction, the pattern in flights, the screw flights, the wear pattern is more, but which are in the horizontal direction, there we found the wear pattern in the shaft. So what we are doing, we are taking out the screw flights from one, and we are taking out the shaft from one, and then again we are joining it together.
So that means it is a different part actually, it's not a single part.
No, there are multiple of screws. Like you saw the video, so there are having 3 to 4 screws, then again it's a horizontal conveyor, it's again having 3 to 4 screws, and one GSC, again it's having 3 to 4 screws.
So those,
there are multiple screws are there.
Sorry, those screws are available as a spare, no, from OEM?
Yeah, like one set we have to keep it because we don't have any other source for unloading the coal. So we have to keep one set ready, always available with us. But again, it requires a lot of OPEX, like around 5 to 6 crore for one set of replacement. And again for belt also it's costing around 12 CRs.
Okay, thank you. Because we are from different industry, we cannot really visualize that. That's why.
Thank you very much. Thank you very much.